All right, looking at now section 11.3, example number 1, we're going to be graphing polynomials of all sorts of degrees. So let's take a look at these simple polynomials. They're simple because they're only one. It's only one term, which I guess you can call it a monomial for mono for one term. But we'll be getting ones that have 4, 5, 6 terms and so forth. And so for this first example, we're just going to look through a few of these, like how do you graph these, and basically we're just going to do this through Desmos. There's, of course, you can bust out a table and do all that, but shoot, dude, this is 21st century, we got Desmos and we got graphing calculators and all that. So I'm just going to take a few of these examples, graph them, and then we'll make some generalizations. Okay, great. So if we just take the first example here, and it doesn't matter really what it is, I'm just going to do 5x to the power, we'll just do 7 for now. Okay, so this is just what it looks like right there, and like you can zoom out, but basically it has this kind of what we call a concave right here, where it kind of it's increasing the entire time, but it kind of has this point of inflection right here. But what's interesting is I'm going to make this actually an A, and then introduce a slider, and just check out what happens as we increase A. So if we go from A is 2, right there, A is 3. I'm wondering, what are you noticing of what's happening to our graph as we just keep sliding this bad boy over? I mean, we can go to 20, right? 20. I mean, now look at this. I mean, if we kept going all the way to 120, we see that the graph is getting more narrow, right? The bigger that A gets, it's getting narrower and narrower. And what if we did, say, something smaller than 1? Like, say if we did like a half, and we did, I don't know, 0.4. Well, let me try that again. We did 4/10, or if we did 5/10, or if we did 3/10, 2/10, 1/10. Do you see what's happening now to our graph? It's stretching horizontally. So just one thing to kind of note right here, and I have this in my notes, and that is that when we have a polynomial that's of the form of a times x to the power of n, check this out. The a is telling us the width of the graph, right? So if the absolute value of a, meaning it doesn't matter if it's positive or negative, the graph is always going to be stretched vertically, making it more narrow. And we saw that, right? Remember how we went up to 120, right? And that thing got pretty skinny. And then if a is in between 0 and 1, again, the absolute value of a, then the graph is going to shrink, or it's going to compress vertically, making it more broader. Okay, so there's just some generalizations right there. So, we can put in 11, we can put in 120, we can put in 1,000, and as you can see, the bigger that gets, it's going to get narrower. Or if we make it really small, like 0.01, 0.001, it's getting wider horizontally. So something to note right there.